This is now the case of a patient with a single lead ICD, with an episode of VT recorded in the memory of the device. We can see in fact that this is not a real ventricular arrhythmia, but there is clearly T-wave oversensing. You can recognize here a sharp signal, which is the R wave, and a smooth signal, which is the T wave. You can see that both of these signals are detected by the device. What is also very important to observe is that T-wave oversensing is observed only when there is a small amplitude R wave preceding it. Whereas here, with an R wave of higher amplitude, there is no T-wave oversensing. So at this time, it is important to know the amplification of the tracing, to have an idea of the exact amplitude of the different signals that we see. So you will click on Adjust Channels and see that the gain of the amplification for the vSense pace channel is at 10 mm per millivolt. You can reprogram it to 1 mm per millivolt, and then you can see the reality of the problem. The main problem in this patient is not a high amplitude T wave, but a very low amplitude R wave, and this is the case in the majority of patients with T-wave oversensing. You need to remember that there is an adaptation of the level of sensibility in function of the amplitude of the R waves, so the lower the amplitude of the R wave, the higher the risk of oversensing the T wave. This is a quite old device, so now the interface has been changed in the new platforms, but there are different parameters that you can modify in case of T-wave oversensing. The first one is the level of sensitivity, but that is probably not appropriate in this case, since the amplitude of the R wave is very low. So if we decrease the sensitivity by increasing this value, then there is a high risk of undersensing of an episode of ventricular fibrillation. The two other parameters that have been designed to avoid T-wave oversensing are decay delay and threshold start. But once more, it is probably not appropriate to modify these two parameters to obtain less sensitivity at the onset of the cardiac cycle in this patient, because there will be also a risk of undersensing of an episode of ventricular fibrillation. When the R wave is very low, the possibilities in terms of reprogramming are very limited. T-wave oversensing must be considered as an emergency, since if an inappropriate shock is delivered in this situation, there is a 50% chance that it is synchronized on the R wave or on the T wave, and if a patient has a high defibrillation threshold, if the shock is delivered on the T wave, so in the vulnerable period there is a high risk of induction of ventricular fibrillation. That is the composite of upper limit of vulnerability. And once the VF has been induced, there is a high risk that defibrillation is inefficient, since the threshold is high. So the association between T-wave oversensing and high threshold is very dangerous, because of the risk of induction and then of non-reduction of ventricular fibrillation. This tracing will be described in detail in the chapter dedicated to the functioning of the Secure Sense algorithm. It is very important to understand that this algorithm has completely changed the management of patients with T-wave oversensing and has considerably decreased the risk of inappropriate therapies in case of T-wave oversensing. You see in this example the markers corresponding to the bipolar channel. This is a discrimination channel. You can see that there is T-wave oversensing on the bipolar channel. T-wave oversensing related to a low amplitude R wave, low amplitude R wave, T wave oversensing. When the amplitude of the R wave is higher, there is no T wave oversensing. But there is a discordance between the bipolar channel, where there is oversensing and short cycles, and the discrimination channel, where there is no oversensing and no short cycles. Therefore, there is a discordance, and the device considers that this is oversensing. And if the counters are filled, the therapies will be inhibited. So you can understand how with this algorithm you can decrease considerably the risk of inappropriate therapies in case of T-wave oversensing. Because now, for therapies to be delivered, you need to have the oversensing at the same time in the two channels, which is quite unlikely.